Welcome to How You Can Ace the Technical SQL Server Interview, where you'll learn how to answer over 25 real-world SQL Server interview questions so your answers don't sound like canned or memorized responses. My name is Mike West, and I'll be leading you through this course. I've been a production SQL Server DBA for over 18 years and want to help you feel more comfortable in a technical interview. I've designed this course for SQL Server DBAs who want to learn how to answer technical interview questions so that the interviewer can be satisfied that you know your SQL Server minutia. Database jobs may be hot, but they're also very competitive. In order to secure one of these jobs, you need the database skills and then you need the interview skills. By the end of this course, you'll be able to answer many of the technical SQL Server questions that pop up in interview after interview. You'll be able to take this newfound knowledge and approach the SQL Server technical interview with greater confidence than you've ever had before. The target audience for this course are production SQL Server DBAs who need to be proficient in many aspects of operational database management. Please take a moment to view the first several lectures of each course. These lectures are free to everyone and will allow you to become more familiar with the instructor's style and his or her approach to the course. Thanks for watching, and we'll see you in the course. Alright, in this lecture, let's decide if this course is right for you. Now, just as an aside, I use the headphone icon to denote a part of a course that only has audio and no video. So this entire lecture will be audio only. Now, obviously I want you to take my course, but with one caveat. I want the course to be right for you. This course focuses on answering technical interview questions you'll likely find in many SQL Server technical interviews. I've been through over 100 technical interviews on both sides of the desk. I've been used by large corporations, including Microsoft, as a technical interviewer, so I have a lot of experience interviewing. Interviewing can be very stressful. SQL Server is a massive product with literally millions of lines of code. Fortunately, most organizations don't have a skilled DBA to complete a thorough technical assessment of each of the candidates. So, what do? They head out to the internet and look for questions that have been used by others. In this course, we aren't going to learn the canned answers to many of these questions. We are going to learn how to craft our own responses so that the interviewer becomes informed by our responses. If you're a mid to senior level SQL Server DBA and want to become more comfortable tackling the SQL Server technical interview, then this course is for you. Now, recently Udemy has made it mandatory that all courses have at least 10 minutes of material at the start of each course. This is great in my opinion. This means the student can watch much of the first section. This should provide the students with an ample amount of information about the instructor's style and the format of the course. I'd also like to suggest you read the titles of each section and peruse the lecture titles. This will also give you additional information and understanding of how the course is laid out. Thanks for listening, and we'll see you in the course. Alright, in this lecture, I want to go over what we're going to cover in the course. Now you may be thinking, hey, wait a minute, didn't you just do that? The answer is yes, but I want to reinforce the specifics of what we're going to do and what we're not going to do. So what are we going to cover in the course? We're going to cover real-world interview questions, and we're not going to answer these real-world interview questions in canned responses. What is the port for SQL Server? 1433, move on. No. What we're going to do is wordsmith our responses in such a way that we not only convey to the interviewer that we know the topic that we're answering about, but we have worked with the topic and understand the underlying perhaps architecture or the way we go about fixing or changing or altering a setting that we're discussing. What this course is not. This course is not a how-to course. Right? When you see the lectures and as you walk down and view the lectures, you may think, oh, he's going to go through these and tell us how to do these things. No, I'm not. Right? That course is all throughout my other courses. For example, I have a question in this course on how to answer a question about troubleshooting the I/O subsystem. Right? not really an easy, simple thing to convey in one lecture. I have a whole course on performance tuning, and within that course are several lectures on working with and understanding I/O. So you might want to take this course and then say, wow, there are some things I don't know that I need to brush up on, and then go take my other courses that maybe are more specific to demonstration of the actual product of SQL Server. All right, in this lesson, let's talk about authentication modes. So the good news is there are only two of them. There are only two ways that we can access any SQL Server in the world. Right? One is through Windows, where Windows does the authentication, and one is SQL Server authentication. Now, in an interview question, we could simply answer SQL Server authentication and Windows authentication, and we would be right. But again, let's give them a little more. Let's tell them where we can change this in the configuration properties. So to change the authentication mode in SQL Server, you're going to open up SQL Server Manager Studio. You're going to right-click on the instance name. You're going to go to Properties, and in the server properties of that instance, you're going to click on Security. And the very first thing you'll see is Server Authentication. There's going to be a Windows Authentication mode and a SQL Server and Windows Authentication mode. 99% of the time, you're going to want SQL Server and Windows Authentication mode. And that's how we change it. Now we want to wordsmith our response. So we know there are only two modes. So let's answer the question in a sentence and give the interviewer the place where we can change it. So here's our response. There are only two types of authentication modes in SQL Server, Windows and Mixed. We can change which mode we need by right-clicking on the instance, going to Properties, and choosing the Security tab. So you've not only answered the question, but you've communicated to the interviewer you know where to change it, which means you've probably done it before. All right, in this lesson, let's talk about and learn about the default port number. So what is SQL Server's default port number? We could simply answer 1433, a closed-ended answer for a closed-ended question. However, let's give a little more. Let's try this as our response. The default port number for SQL Server is 1433. We can change it using the SQL Server Configuration Manager in the Protocol section for security purposes if we need to. Once we change the port number, it will require a reboot, and we'll need to use the port number in our connections every time moving forward. So what we've done is answered the question, but we've added two more sentences, and those sentences have added a much greater impact to our answer. We've given the interviewer several more pieces of information in addition to just answering the question. We told them where we can make the change, SQL Server Configuration Manager. We told them why, for security reasons. We also let them know that we need to reboot the instance and then how to connect after the port has been changed. All right, so don't memorize my wording. Take the sentence and paraphrase it so it sounds like it's coming from you. You don't want this to sound like a canned response. All right, in this lesson, let's learn the difference between a local and a global temporary variable. Now, this often confuses people, but once you see it, it's obvious. So, a local temporary table exists for the duration of the connection. A global temporary table remains in a database permanently, but the rows exist only within a given connection. When the connection is closed, the data in the global temporary table disappears. However, the table definition remains with the database for access when the database is opened the next time. And in our example here, we can see the difference. All right, let's go on to wordsmithing our answer. All right, let's craft the answer we're going to use during the interview. We create a local temp table. Notice I put temp. We don't have to say temporary every time. We create a local temp table by placing a pound sign in front of our table definition. We create a global temp table by placing 2 pound signs in front of our table definition. A local temp table only exists for the duration of the connection. A global one can be used outside of our connection. In our first two sentences, we are defining what they are, right? We're telling the interviewer, hey, this is a local temp table, this is a global temp table. This is how we create it, right? What's the difference between the two? One exists for the duration of the connection, one can be used outside the connection, right? This is a very simple definition, it's very effective, and gives the interviewer more than they need. All right, in this lesson, let's talk about log shipping. Now, some people will say that log shipping is a tool for high availability. I think one could argue that point because of the fact that there is no automated failover in log shipping. You have to do it manually. I like to use it as a disaster recovery tool. Either way, log shipping involves copying a database backup and subsequent transaction logs from the primary or the source server and restoring that database and transaction logs to one or more secondary standby or destination servers. The target base is in standby or no recovery mode on that secondary server. So that allows for subsequent transaction logs to be restored to that secondary server. All right, so now we know what it is. Let's go ahead and craft our response. Log shipping involves copying a database and transaction logs to a standby server. The standby server is in standby mode, meaning we can't access it until we manually bring it online in a disaster. Now, we've defined what it is, right, in the first sentence. And in the next sentence, we let the interviewer know the mechanics behind log shipping. That it's in standby mode, it can't be accessed, and we can't bring it online until there's a disaster. All right, so we've done a lot in that second sentence that helps the interviewer know that we know what log shipping is. All right, I've seen this one a lot. Let's learn about the benefit or the non-benefit of indexing foreign keys. So first, what's a foreign key? Separate from primary keys, very related, are foreign keys. A foreign key is a column or a combination of columns that is the same as the primary key, but in a different table. Foreign keys are used to define the relationships to enforce the integrity between two distinct tables. Now, unlike primary key constraints, when a foreign key constraint is defined on the table, an index is not created by default for SQL Server. That doesn't mean it's not uncommon for developers and database administrators to add them manually. Is it a good idea to create an index on foreign key columns? Yes. Why? Because you not only support the joins between the primary and the foreign keys, but also the updates and deletes, something that seemed to be forgotten when we talk about indexes. Now, keep in mind, this is a general recommendation, and there are going to be other scenarios where this might not be beneficial. All right, let's go ahead now and craft our response. So, the majority of the time, it's a good idea to index foreign key columns. All right, notice we said the majority, right? Doesn't mean it's always the best practice. This not only helps with the joins between the primary and foreign keys, it also speeds up the deletes and updates. Right? So we've let the interviewer know it's good practice to index the foreign keys. It helps between the joins of the primary and the foreign keys. And it also helps with deletes and updates. Again, what we're doing is helping to reinforce our knowledge of the specific idea. In this lecture, let's learn about the clustered index. This is possibly the single most asked question in every interview. Now, instead of answering the question, what is a clustered index, let's go beyond that and give a complete answer that shows we understand all the data access methods in SQL Server, not just what a clustered index is. So, there are three ways we can access our data in any query. First is via a heap. A heap is a table without a clustered index. The second is via a table with a clustered index. A clustered index means the rows are physically reordered to match the index. A table with a clustered index is called a table with a clustered index. The last way we can access our data is via a non-clustered index. A non-clustered index is a separate structure that is made up of index pages instead of data pages. When we access our data using a non-clustered index via a heap, we do so using a row ID or a RID. And when we do so via a clustered index, we do so with a clustered index key, which is often referred to as a key lookup. So, we've not only answered the definition of our original question, what is a clustered index? We've defined every access method for data retrieval in SQL Server. This shows the interviewer we have a complete view of data access in SQL Server. Alright, let's take a minute to trim down the answer because that's a lot to memorize for an interview. So here's the final one. We can access data in SQL Server in three ways. The first is via a heap. The second is via a clustered index, where the rows are physically ordered to match the index. And lastly is using a non-clustered index. With this, we've still answered the question by defining the clustered index, yet we've expanded on the original question, thus letting them know we have a complete and comprehensive view of access methods in SQL Server. Alright, in this lesson, let's learn the difference between a primary key and a unique key. Both a primary key and a unique key enforce uniqueness of the column on which they are defined. But the default primary key creates a clustered index on the column, whereas a unique one creates a non-clustered index by default. Another major difference is primary keys don't allow nulls, but unique keys allow one null. Alright, so now that we have an overview of what that does, let's look at the high points and then we'll create our statement after we look at the high points. Alright, so let's look at the 4 core points. Both enforce column uniqueness, so we need to remember that. The primary key creates a clustered index. The unique key creates a non-clustered index. Unique keys can have only one null. Alright, so now that we've got those high points out of the way, let's go ahead and recraft our statement. So, a primary key and a unique key enforce uniqueness on the columns in which they are defined. When you create a primary key, a clustered index is automatically created on that column. A unique key creates a non-clustered index that can have one null value. Again, a really good way to approach this is to look at the high points, read my definition, and then write down your definition. Whatever it takes for you to remember the key aspects of the difference between these keys, so you can just let this flow when it's asked in an interview. Alright, in this lecture, let's learn the difference between the truncate command and the delete statement. This can be a trick question if it's being asked by a skilled DBA. If not, you can act as a myth buster and craft your response in a way that doesn't sound too condescending. So the question is, what's the difference between the truncate command and the delete statement? The real answer is not much, but that's not often what the interviewer is expecting. Firstly, let's dispel the myths. First myth, truncate is faster because it logs less actions to the transaction log. Nope, it doesn't. It may be faster, but it has nothing to do with the logging, and it certainly does not log fewer transactions. I've tested this several times, and I've actually written several blog posts on it. The logging for a delete statement and truncate statement is about the same. Now, if you go back and watch this in the beginning, you'll see the demonstration I'm giving you is the demonstration showing that there's actually more logging with our truncate command in our example than there is with a delete statement. Alright, so let's hit the second myth. The truncate command can't be rolled back. It can be rolled back because it's logged. Alright, so let's take a second to dispel all this non-logged conversation. In SQL Server, there is no such thing as a non-logged operation in a user database. The only non-logged operations that SQL Server performs are those on the version store in TempDB. Alright, so after we've gone through all this, then what is the major difference between the two? A truncate table operation does a wholesale delete of all the data in the table. The individual records are not deleted one by one. Instead, the data pages comprising the table are simply deallocated. The delete removes rows one at a time and records an entry in the transaction log for each of these deleted rows. Now, to be honest, the biggest real-world difference for you and I is the where clause. The delete statement allows us to specify a where clause so we can delete ranges of data. We have a much greater control with the delete statement. Alright, let's go over the core points to this question. truncates a logged operation. Delete removes individual rows. Data pages are deallocated with the truncate command. We use the where clause with the delete. All right, now let's move on to our definition. The truncate command is a logged operation that deallocates the data pages at one time. The delete statement removes the rows one by one. The biggest real-world difference is that we can use the where clause for greater control of what we are deleting. In this lesson, let's learn about the difference between statistics on a table and statistics on an index. So, there's essentially no difference between the stats on an index and the stats on a table. They're created at different points, and unless you're creating the statistics manually yourself, they're created slightly differently. The statistics on an index are created with the index. So, for an index created on pre-existing data, you'll get a full scan against the data as part of the task of creating the index, which is also then used to create the statistics of the index. The automatically created statistics on columns are also usually created against existing data when the column is referenced in one of the filtering statements, such as on a where or join. But these are created using sample data, not a full scan. Other than the resource and type of creation, these two types of statistics are largely the same. Is there a formula for updating these statistics? Yes, there is. As data changes in your tables, all of these statistics will be updated based on the following formula. When a table has no rows and gets a row. When 500 rows are changed to a table that is less than 500 rows. And when 20% plus 500 are changed in that table greater than 500 rows. By change we mean if a row is inserted, updated, or deleted. So yes, even if the automatically created statistics get updated and maintained as the data changes. So what are the scripts and tools we use to help us maintain these statistics? SQL Server has two of them. SP update statistics will look at all the statistics within the database to see if any rows have been modified in the table that the statistics support. If one or more of the rows have been modified, then you'll get a sampled update of the statistics. The next one is update statistics. This will update the statistics in a way you specify against the object you specify, whether it is a table, an index, or a specific set of statistics. So what does it mean when I update statistics with full scan? Okay, the key word and tricky phrase that you can have a look at here is with full scan. That indicates that the full data set is used to create or update those statistics. Since rebuilding an index is, to a degree, almost the same thing as creating the index, you're getting a full scan of the data set to put that index back together. This full scan also updates the statistics. If you run update statistics with full scan, once again, it's looking at all the data. Are statistics created on temporary tables? The answer is yes. The major difference between a table variable and a temporary table is that the temporary table has statistics. The rules for the creation and maintenance of these statistics are exactly the same as a regular table within SQL Server. All right, let's go ahead and wordsmith our answer. Now, what we're going to do, no matter what the question is, if it's the first question on statistics, no matter what it is, define what statistics are for the interviewer. So let's say that the first question is, what's the difference between the statistics on a table and the statistics on an index? Here's our answer. SQL Server's Query Optimizer uses stats to determine how it's going to satisfy a query. Now there's no difference between the stats created on an index and those created on a table. So we've really answered the question that we've been asked, right? What's the difference between the stats on an index and a table? There isn't any. But we've also defined for the interviewer that we know what statistics are. All right, now this question is usually reserved for mid to senior level candidates. However, I have seen it, and I've seen it more than once. So when do these statistics change on a table? All right, so firstly, when a row is inserted into an empty table. Now, that will be the easiest for you to remember. All right, so you really have to focus on the second two, right? Secondly, when a table has less than 500 rows, and there'll be an increase in 500 or more since the last update. All right, that's the wording, that's just tricky. Thirdly, a table has over 500 rows, and there's an increase in 500 plus 20%. All right, so how can we more easily remember our second and third chance options there? All right, so 500 is the key, right? 500 is the key for second and third. So when a table has less than 500, so we have to think less than 500, and there's an increase in 500 or more since the last update. All right, that's how it's going to be easier for you to remember number two. Number three, table has over 500. All right, again, the 500 is the common denominator in secondly and thirdly. So all we have to do to remember second and thirdly is focus on the 500. It has over 500 rows, and there is an increase of 500 plus 20%. So for thirdly, just think 500 plus the 20%. And this really is the way we want to answer the question. So our answer really would be statistics change on a table when one of three things happen. Firstly, when a row is inserted into an empty table. Number two, when a row is less than 500 rows and there is an increase in 500 or more since the last update. And three, a table has 500 rows and there's an increase in 500 plus the 20%. All right? So this may take a little while to memorize, right? Again, the first one will be easy when a row is inserted into an empty table. The second two, you're probably going to have to write down and wordsmith how you want to answer this in your own words. All right, in this lesson, let's learn about the benefits of stored procedures. This one you're going to see a lot, or at least you should, because stored procedures over ad hoc are very beneficial for real-world production systems. So, what are the advantages of using stored procedures? Number one, the stored procedure can reduce network traffic and latency, boosting application performance. Number two is the big one. Stored procedure execution plans can be reused, staying cached in SQL Server's buffer cache, reducing server overhead. Number three, stored procedures help promote code reuse. Number four, stored procedures can encapsulate logic. You can change stored procedure code without affecting the clients. Stored procedures provide much better security for your data. They're a lot less hackable. All right, let's craft our answer for our interview. The biggest benefit is going to be caching, so we want to emphasize that in our very first statement. So we do. The biggest benefit stored procedures offer is caching. The first time a stored procedure is executed, its plan is placed in the buffer pool. Notice I didn't say its results are placed in the buffer pool. It's not. The plan is. We can use the same execution plan time after time. They, stored procedures, we could also put instead of they, stored procedures. They also help promote code reuse and provide better security than ad hoc queries. So we've done a lot here, right? Other than simply defining or answering the interviewer's question. We've given them our opinion on what the biggest benefit is. All right, it's caching. Right. We've told them we know what the buffer pool is. Why? Because we've said a stored procedure is executed, its plan is cached. We've also let them know about the plan. We know what plans are, right? We have to if we say its plan is cached in the buffer pool. In the next sentence, we let them know what caching is. How? Because we can use the same execution plan time after time. Right? We have to know what caching is, and we've demonstrated that to the interviewer by telling him the execution plan can be used time after time. And in the last sentence, we've given them some other things other than caching that stored procedures help. They help promote code reuse and provide better security than ad hoc queries. Right? We've also let them know we know the nomenclature of these SQL Server queries, right? Stored procedures and ad hoc queries. We've let them know we know what an ad hoc query. An ad hoc query is when someone walks up to Manage the Studio and types in select all from whatever. So this seems simple at first, but it really is a loaded, comprehensive answer. All right, in this lesson, let's talk about the buffer pool. Now, understanding how pages flow between the buffer pool and the disk subsystem really is paramount to understanding and answering a whole lot of interview questions. So, in SQL Server, data in a table is stored in pages. Pages is the fundamental unit of storage for data in SQL Server. Each of these has a fixed size of 8 KB. Whenever there's a need for a page, a read or write, the page is first read from disk and brought into memory. This area in SQL Server memory is called the buffer pool. Once the page is loaded in memory, all the subsequent calls which need this page will be read from the buffer pool. This would avoid disk I/O and hence improve performance significantly. This is the precise reason why memory usage in SQL Server is high, even if no one is using SQL Server. Once a page is modified in memory due to a data modification, an insert, update, or delete, it's called a dirty page. On the other hand, if the page is not modified, it's called a clean page. Let's tackle the first question you'll often see when it comes to data storage, and that is, how is data stored in SQL Server? So here's our answer. Data is stored in pages. Each page is 8 KB. These pages are grouped together into extents. Now, an extent is simply 8 contiguous pages, right, or 64 KB. An extent is 8 pages. There are mixed extents and there are uniform extents. All right, so we've gone beyond answering the question, right? We've defined what a page is in the very first sentence. We've defined its size, and we also let the interviewer know a little more about their architecture, that these pages are grouped into these items called extents, and there are two different kinds of extents, mixed and uniform. So what are extents? Extents are simply the basic unit in which space is managed. Uniform extents are owned by a single object. All 8 pages in an extent can be only used by the owning object. Right? Mixed extents are for shared group objects. Each of these 8 pages in the extent can be owned by different objects. So in a mixed extent, you could have a table, index, index, table, table 3, table 2. In a uniform extent, you have table 1, table 1, table 1, table 1, and you would have table 1 through the entire extent. All right, in this lesson, let's answer some page-related questions, or learn a little bit about how the page moves. When a page is in memory and it's in the buffer pool, it's a clean page. When that page is updated, either by a user query or by the system, it's referred to as a dirty page, simply because the version in memory is different from its counterpart on disk. Now, the process, called a checkpoint, will write that page from memory to disk. So until a checkpoint process runs, the page in memory is still dirty. After that checkpoint process runs, the page is marked as clean. All right, let's talk about the question that might arise from this, and that question usually is, what process flushes the page to disk? All right, they won't ask that until you've answered the page question, but once you've answered the page question successfully, then they feel, well, he or she knows what a page is, it's time to up the ante. So what's the process? So we want to give the interviewer more than just saying checkpointing, right? One-word answers really aren't very good in interviews. So let's walk the interviewer through the process with a few sentences. And this is really a good way to do it. When an unmodified page is in the buffer pool, it's called a clean page. Once that page has been modified, it's called a dirty page. The process of flushing, the keyword is flushing there, that's what happens, and that's the terminology you want to use. Flushing that dirty page to disk is called checkpointing. So we've not only answered what the process of moving that dirty page to disk is called, it's called checkpointing. We've discussed the buffer pool. We've discussed that the modification happens and it becomes a dirty page. We've done a whole lot in, 3 sentences. And that really helps cement in the interviewer's mind that not only do you know the answer, what checkpointing is, but you understand the process, which is equally, if not more important. All right, in this lesson, let's learn about GUIDs, or in more recent SQL Server versions, unique identifiers, as the primary key. Now, there's been a lot of talk and a lot of discussion that this is a horrendous idea. Unfortunately, that's not so correct. There's really nothing wrong with GUID keys and clusters in an OLTP system unless you have a lot of indexes on the table that suffer from an increased size of the cluster. As a matter of fact, they are much more scalable than identity columns. There's this widespread belief that the GUIDs are a great problem in SQL Server. Now, as a general rule, this simply is wrong. As a matter of fact, the GUID may be significantly more scalable on boxes with more than 8 cores. Now, the case study in this is laden in technical minutia that's beyond the scope of this lecture. However, it has been proven by a SQL Server expert who deals in scale that the GUID will actually outperform an integer on scale. All right, remember when I said we're going to have to tiptoe and sometimes educate the person that's doing the interviewing? Now, this is one of those cases, particularly when it's a developer who has been trained and knows only about the traditional methods of building relational systems. All right, so let's see if we can't give an answer that informs yet doesn't set up a contentious scenario for the interviewer and the interviewee. So here we go. Traditional SQL Server thought dictates that the identity is often the best choice for a primary key. With lower scale systems, sequential keys are a good choice because they reduce fragmentation. However, on larger scale boxes, the clustered sequential index may not be the best option. Now, if the interviewer presses you on why, you can simply respond that tests on boxes with 8 or more cores, again, larger scale, have shown that GUIDs perform better. And then you can say that you will point them to an article from Thomas Kaiser, who is considered the king of scale, on the clustered index versus the heap. That is the name of the article. Now, you don't want to get into an argument in an interview. That's a bad scenario. Even if you're right, that's not what you want to do. However, this is a point where you can say, I don't recall all the specifics of the article, but I can forward you the article and look at the test results together. All right. So that does a few things. All right. So that kind of response, all right, that you don't know it all is really good. Right. And also that you can look at the results together, meaning if they offer you a job, you can show them and walk through the test with them. All right. So this is one of those you're going to have to tiptoe around. However, it is a great opportunity to inform and to show you have knowledge outside the traditional world of the best practice. All right, in this lesson, let's learn about the ACID properties. The ACID properties are absolutely one of the most asked questions you'll ever see in your life. So, what are ACID properties? These are the properties of a transaction, right? So when a transaction processing system creates a transaction, it will ensure that all the transactions will have certain characteristics. So what are these characteristics? Well, ACID is an acronym. The A stands for atomicity, C consistency, I for isolation, and D for durability. So the atomicity, this property identifies the transaction as atomic. It simply means it's either full or completed, or it hasn't begun at all. There is no in between. Consistency. If a transaction completes successfully, then all the changes to the system have been properly made, and the system is in a valid state. If an error occurs, the changes are rolled back. So, consistency means a transaction can't leave the database in a state other than what it found it in when it started. Isolation. Isolation means just that the transaction is isolated. If there are two transactions both performing the same functions and running at the same time, isolation means that the transaction will execute and the other one will have to wait. Durability. A transaction is durable in that once it has been successfully completed, all the changes it made to the system are permanent. Durability means that there are safeguards to prevent the loss of information, even in the case of system failure. By logging the steps of a transaction into the transaction log, the state of the system can be recreated even in the event of a hardware failure. All right, so now we know what this means. Let's bring all this together. All right, even though this is one of our longer definitions, we're really going to put a stamp on this by defining one of the ACID properties. So let's begin with the entire statement first. ACID stands for atomicity, consistency, isolation, and durability. These properties guarantee database transactions are processed reliably. For example, durability is implemented by WAL, or write-ahead logging. WAL states a record or image must be written to the transaction log before it's written to disk. Now, what we've done in the very first sentence is give them ACID. What is ACID? Well, this is what it stands for. In the second sentence, we've defined what ACID is, what all these means. These are the properties that guarantee database transactions are processed reliably. And then everything after this is really icing on the cake. Right? So we're giving them an example of one of these properties. And not only is it an example of one of these properties, there's a deeper grain of knowledge here. WAL probably won't be known by the person doing the interview. So you really get some bonus points here by giving them examples how SQL Server implements the durability in ACID properties. All right, in this lecture, let's talk about, or let's learn and define, performance tuning. So a lot of questions will be related to performance tuning because that's going to be a big part of your job as a SQL Server DBA. And it turns out we can boil down performance tuning to two core concepts. The first is we want to reduce resource consumption on the instance, or actually on all the resources that SQL Server uses. Well, what are the three core resources that SQL Server uses? CPU, memory, and I/O. I/O being the disk subsystem. Secondly, we want to improve transaction speeds. Now, we're speaking specifically to OLTP boxes here. We want the transaction speeds to be as fast as possible. So now that we've refined what performance tuning is and what are the two things we're trying to accomplish, what are the different approaches? Well, again, we have two approaches to choose from. We have a top-down and a bottom-up. The bottom-up is the one all of us know about. That's being able to use execution plan analysis to look at the individual queries and make changes so that they run faster. The other is the top-down approach. This is one I like because it's less intrusive, and in the end, it does a better job of satiating our two core concepts, the reducing resource consumption and improving transaction speeds. Top-down means we're going to go to SQL Server and we're going to start tweaking all the buttons and knobs associated with SQL Server. We're going to look at TempDB. We're going to look at the cache. We're going to do a lot of things to ensure SQL Server can perform optimally before we go to the bottom-up approach. And why is that? In my opinion, the bottom-up approach is the most intrusive. When you go into many organizations, they have third-party applications, and you won't even be allowed to touch the code because of the contractual obligations they have with these third-party organizations. You're going to have to understand the top-down approach. Either way, now we know what performance tuning is. We know the two core approaches. Let's wordsmith our answer. All right, let's read our definition. Performance tuning consists of two core components. The first is the top-down approach. With this approach, we are tweaking settings within SQL Server to ensure the instance is running optimally. The second goal we strive for is to reduce resource consumption on the instance. So we've let the interviewer know there are really two core components to performance tuning. Our definition, we've let the interviewer know what performance tuning is, what are the two key approaches, and what they are. Notice these key words also that don't jump out unless you really know SQL Server. For example, within SQL Server to ensure the instance is running optimally. Instance. Why the instance? Well, because the instance shares the big three. Instance shares CPU, I/O, and memory. So we want them running optimally because all the databases on that instance share these critical resources. And if all those critical resources aren't up to snuff, and the whole box is going to run like crap. So with our definition, we've not only defined what performance tuning is, we've used some words that senior level SQL Server DBAs and those that are really in tune with what performance tuning is be satiated by your answer. All right, in this lecture, let's give a real-world performance tuning scenario. Because once the interviewer asks you about performance tuning and the definition, and once you give it accurately, the next question is undoubtedly going to be, well, can you give us a scenario where you have implemented a performance tuning technique that has added value to the box? Yes. My favorite one is TempDB. TempDB suffers from two different kinds of contention, right? There is contention for bottleneck for threads trying to access allocation pages that are in memory. That's called latch contention. And one is I/O contention, meaning that oftentimes there's only one data file on instances that have many databases. That means all the temp tables that are being used by all the databases on that instance are going to beat up TempDB. And if you create multiple data files, it spreads out that load. So why do I like it? It's not intrusive, it's easy to do, and it causes no harm if you're wrong. So we come up here to databases. We click on System Databases. We right click on TempDB, and we go to Properties, Files, and here we are, TempDB Dev. So we want to add 4 more of these. We'll call this Temp Dev 2. Yeah, that's great. Yeah, we don't want to grow these in percents. It doesn't matter what we call them. We want to add 4 more. So here's 1, 2, 3, 4. Now the trick is, look at the initial size here. The trick is these all need to be sized equally. All right, so that's one of the caveats about this. So we want to size them equal to whatever this is, or we want to shrink and then resize. However you do it, you want these all to be the same size when you create the file. So here's 12 megs. We want these all to be 12 megs. We don't want to touch the log file. Only one log file, remember. Start with 4 data files. All right. So why do I like to implement this? Like I said before, it is non-intrusive. I can do this on a live box in the middle of the day, and chances are no one would know it. Now, you don't want to do that. You want to implement it during a downtime window, just in case. But you can do it without a reboot. This doesn't necessitate a reboot, so you can add these live. So this is a great example of something you've done to a instance of SQL Server to make it more performant. All right, now let's wordsmith our response. All right, so here's our response. One of my favorite performance enhancements is adding additional TempDB data files to TempDB to eliminate latch contention and also help eliminate I/O stress on the primary data file. This performance tweak is non-intrusive, doesn't require a reboot, and can have immediate positive impact on the instance. So we've done more than just answer the question, what is one of our favorite performance tweaks? We've answered it, but we've answered it in quite a bit of detail. Number one, we said one of my favorite performance enhancements. That means that you have more, right? Adding additional TempDB data files. You've given them the reason why. To eliminate latch contention, that's number one. And to help eliminate I/O stress, that's number 2. So you're getting 2 benefits from this one implementation. Next, you're letting the interviewer know you know the impact of this. It's non-intrusive, it doesn't require a reboot, and can have immediate positive impact on that instance. Now, you're using the word instance, right? Going back to this idea that the instance is what shares the 3 critical resources. Remember that. That's a very important aspect to performance tuning as a general rule, right? The instance shares memory, I/O, and CPU. The more databases you have on there, the worse it is for TempDB. All right, one of the questions you're going to see often is on high availability. And high availability means keeping your systems available so the applications can continue functioning in an outage. Now, don't get high availability and disaster recovery confused. Disaster recovery means you've got something in place that if a bomb hits your data center, your core data center, you have a way to bring your applications and the data with them online, right? That's not high availability, that's disaster recovery. Let's talk about the big 4 in terms of high availability. Number 1 is clustering. And in the last several versions, it's been changed. The name has been changed to always-on failover clustering. It's the best option, in my opinion, for high availability. It's designed to reduce unplanned downtime by allowing clustered services such as SQL Server to automatically fail over to a backup node when a hardware or software failure makes the primary node all available. So in clustering, the whole instance fails, right? If something goes wrong with that box, it fails over to the second box. Second is database mirroring. Mirroring works by forwarding transaction log entries from the principal to a mirrored database, and it can be set up either synchronously for high availability or asynchronously across the WAN for disaster recovery. The second one is log shipping. Now, I don't see log shipping as a high availability option, but a lot of people do. Log shipping works by periodically running a stored procedure that forwards transaction log entries to one or more destination servers. Unlike mirroring, which works in real time and is capable of automatic failover, log shipping requires manual failover and failback. Last but not least, everyone's favorite, always-on availability groups. Always-on availability groups can replicate multiple databases to as many as 4 replica systems with a mix of both synchronous and asynchronous replication of the transaction log. It fully supports automatic failover. Always-on availability groups are found only in the Enterprise Edition of SQL Server. So now that we've gotten a 10,000-foot view of what these options are, let's go ahead and craft our response. All right, this will certainly be our longest definition, but that's just how it is. There are 2 core HA, high availability options in SQL Server. The first is always-on clustering. This is the traditional cluster where a node will fail over to another node in an outage. The second is always-on availability groups. With this option, availability databases fail over together on different replicas. All right, so what are we doing here? There are 2 core options, right? The first is always-on clustering, and the second is always-on availability groups. Can be confusing because they both start with always-on. I hate it. I didn't come up with the names. Clustering is the traditional cluster where the nodes fail over to another node. The entire node fails over, right? The word node is important. That is the vernacular specific to clustering. You can see with always-on availability groups, databases fail to replicas, and there's a primary and a secondary replica. However, we can only communicate so much information to the interviewer when they ask this 10,000-foot view of our options. All right, so we've got these 2 core ones, and now let's go look at the secondary ones. The secondary options are mirroring and log shipping. Mirroring provides HA and protection for a single database. Again, HA, high availability. Log shipping involves backing up the transaction logs on the primary and restoring them to the secondary. The primary and the secondary is the terminology used for the servers in a log shipping scenario. Key here, there is no automated failover option with log shipping. So it can be done with the other 3. However, it can't be done with log shipping. So we've got our 2 core and our 2 secondaries. Again, if you break it up like this and mention the core and the secondary, it will really help reinforce the fact that you understand what the two real-world options are. Very few companies are going to set up high availability options with log shipping. I promise you, I don't think I've ever seen it. The way we've crafted our sentences here shows that we have these two core options, and these would be the two we would recommend if we were coming into the organization to set up high availability.